Okay, if you happen to miss my lecture about graphing that we just did, you can do these video notes and get all of the information that you need. You can also rewatch it if you thought it was so exciting and you just want to hear it again. So you should have your packet open to page 15. And the first thing you need to do is fill in the KWL chart at the top. There's a column for what you know about graphs. Fill in what you think you know about graphs. So those are things that maybe you're not quite sure about, but you think you know, and what you want to know about graphs. And even if you don't want to know anything about graphs, which you probably don't, and I understand that, humor me and just come up with at least one question, something about graphs that you could possibly ask. For the what you know and what you think you know, if you want to use examples of types of graphs, you can write down some graph types as well. So if you need time to do that, go ahead and pause me. Otherwise, you can continue on. We're going to be looking at two separate essential questions here. The first one is, how does a graph help you organize data and interpret trends? And that one, I'm not really going to tell you how it does that, but you're going to see examples of how the data goes from being just a pile of numbers on a data table to a nice organized graph that you can really see. Underneath your KWL chart, you'll see numbers 1 and 2. Number 1 is this, data, so you're going to write data in that blank line. It's information gathered through experiments, so experiments goes on the other blank line. The screen actually has a few more words than your paper, and that's okay. Number 2 then is analyze. So you'll fill in analyze on the blank in number 2, and that is to study or determine the relationship between parts. The second essential question we're going to be looking at is, how do the purposes of line graphs, bar graphs, and pie graphs differ? Although there's probably 100 different types of graphs, I'm only going to talk about line, bar, and pie graphs because those are the 3 graphs you are most likely to encounter in science class this year. All right, so something you don't know about me. I like to hang out in a tree over at Memorial Park, and this is what I do over the summer. I climb up in trees at night and with my little clipboard, and I observe werewolves. So I kind of hang out in the tree all night, and I just write down the number of werewolves that I see. So this is my data table from the past summer, and I'm going to explain this to you. So this row is time and days. So because I didn't see a werewolf every single day, I just recorded the number I'd seen every 5 days. So, for example, after the first 5 days, I had seen 4 werewolves. This way, I don't have a data table that goes all the way up to 75 boxes on it. After 10 days, I had seen 2 more. The next 5 days, I saw another 5, etc., etc. Now, if you are anything like me, you might look at a data table like this with all these numbers and your brain just says, oh, no way. Nope. That's a whole lot of nope right there. And that's okay. This is why we have graphs. So I went ahead and put it into a nice line graph. So a couple things about line graphs, which will help you when you get to making your own line graph in a couple of days. First of all graphs should have a good title. The title should tell you what information you're going to be seeing on that graph. So when I read this title, werewolves seen over time in Mechanicsburg Parks, that tells me that there's going to be a number of werewolves over some time period. I could have said over 75 days. That would also be an acceptable thing to write in the title. The x-axis, I hope you know that this is the x-axis. If you don't, you do now. This is the y-axis. So the x-axis has time. You can see I labeled it time, and in parentheses I put days. That tells you that these numbers are days, number of days. If I did not put days, we wouldn't know if that 5 meant 5 minutes, 5 seconds, 5 hours, 5 weeks. You get the idea. So because I put time and days, that makes it very clear that these are numbers of days along the x-axis. Going up the side, I have number of werewolves seen. So that tells you these numbers are how many werewolves I saw during each of those time periods. Now, another really important thing when you're making line graphs is to make sure your numbers are evenly spaced and at even intervals. So by interval, I mean, these are by fives, 5, 10, 15, 20. So you can't go 5, 10, 11, 12, 20, 40, 80, 100. Those aren't even intervals. You could go by twos, you could go by fives, you could go by 10s, 20s, 25s, 50s. It doesn't matter. Just make it fit your data. Because my data was already in 5-day chunks, I went with fives here. I'm going up the side then, again, evenly spaced, even intervals. So I went by twos. I could have gone by ones. I could have gone by threes, fives, tens. But you need to do what works best for your data in your graph. If I'd gone by ones, I'd have a really, really tall graph. If I went by 25s, all of my items would be shoved under one. So twos worked out really well for me because everything is either on a line or halfway. So that is how you would set up your line graph. This line graph in particular, you can see those two big spikes. And those two spikes, they look like tall mountains. Whoop, right here, boom. And right here, boom. Those two spikes tell you, of course, that I saw a lot of werewolves on those two during those two time periods. If you think a little bit further into it, you might realize that those spikes probably correspond with full moons. They're about 30 days apart, which is about what full moons are. So that's part of the analysis that we can do with a graph. So this is a lot easier to read and understand than that huge data table we looked at on the last slide. And this can help us to get to that next step where we see, oh my goodness, these must be full moons. That makes total sense. Now, I did get a few pictures of the werewolves while I was out. So brace yourselves, because I'm going to show you these pictures. Just kidding. So that was a really scary encounter. You're actually lucky I'm sitting here today talking to you, because this one almost got me. This one was also very scary. I was very fortunate it did not turn its head and look at me, because I was scared. I don't think it saw me. It was kind of growling at someone else. All right, so now down at the bottom of your organizer on page 15, you see the word line graph and a box. Fill this into the box. And of course, if you need more time than I'm giving you to write something, just hit pause and play me again when you're ready. Another thing I like to do over the summer is go to the city and hang out with my friends. Now, I cannot reveal my superhero identity, so I left myself off of this chart. But while I was there, I kept track of how many lives me and all of my friends saved. And you can see my data table right up here. Captain America saved 83 lives. The Hulk saved 43. And if you ask me if he would get control of his anger issues, he would probably be able to focus on more life-saving and less breaking things. Hawkeye only saved 26 lives. He's obviously a slacker. Thor saved 59, Iron Man saved 70, and Black Widow saved 33. So that's the information I collected over the summer while hanging out with my friends in the city. And again, I'm going to put that into a format that's a little bit easier for us to see. But first, I want to show you their baby pictures. Aw. Okay, so here's a bar graph. You can see again, I have a good title, Number of Lives Saved per Avenger. So reading that title shows me exactly what information I'm going to find. Down on the x-axis, I have Avenger. So if you don't really know your superheroes very well, you now know that these 6 people are Avengers. And I'm also an Avenger, but again, secret identity. Going up the y-axis, I labeled number of lives saved. And then in this one, I went by tens. So again, I could have gone by 5s, 2s, 50s, 100. But you need to do what works best for your data and the size graph that you're trying to make. One of the things I love about bar graphs is that you can make the bars all different pretty colors. So in this case, I took my friends' favorite colors and I made their bar out of those colors. So clearly Captain America is awesome. You can see up here how tall his graph is, or how tall his bar is, And you can see that very quickly. As soon as you look at the graph, right away, that kind of jumps out at you. And Hawkeye's very poor performance also jumps out at you very quickly. All right, so again, at the bottom of page 15 in the box labeled bar graph, you can fill this in. It's used to compare different groups in relation to each other. Finally, the last thing I do is sometimes my inner nerd takes over and I go outside and I play Pokemon Go. This is older data, so I apologize. It might not be accurate, but it gets the point across. So we're taking a look now at percentages. There's probably several million players on each team, and sometimes that can be very difficult to make a graph out of. And in this case, it works very well to make a pie graph because a pie graph is going to show you percentages of the whole. Now, the whole pie would be 100%. So your numbers in the pie graph should add up to 100. And in this case, they do. You can do the math yourself if you don't believe me. So here's my pie graph. Again, we have a nice title, percentage of Pokemon Go players on each team. I've got the 3 chunks of pie. I have percentages labeled on them because you can't always look at the graph and know exactly what percentage it is. I also have a key over here telling you which color goes with which team. The key is not totally necessary. I could write the team names right on my pie slices, but I like the key because it's pretty colors. I could also, if I wanted, I could put the percentages over here in the key. So that some of that's just personal preference. And when you make your own pie graph, you can decide how you want to do it, as long as all the information is somehow contained on your graph and easy to find. So your last item then is filling in the pie graph box at the bottom of page 15. And when you're done, you can go ahead and stop this. And then it's probably time to get to work on your graphing assignment. So thanks for watching.